Hello, I would ask that you pause the video right now and see if you can practice what the last lesson was and answer the questions from this line graph. So hopefully you paused the video and you were able to come up with the same answers that I do. So looking at the graph, how many people were in the store at 11 a.m. So you go over to that 11 a.m. on the timeline down at the bottom, and up there you can see that there were 5 people. What time interval did the people in the store decrease the most? So you're looking for the greatest slope. And so notice that the biggest decline goes from 2 to 3 p.m. And then what was the first time that the store held 10 people? So if you're looking on the y-axis at 10, the first spot that I see would be at 12 p.m. All right, so let's continue with section 1.2, linear and rational equations. We are still solving these equations, but now we're also going to recognize identities, conditional equations, and inconsistent equations. Okay, so let's define what these things are. Equations can be placed into categories depending on their solution set. An identity is an equation that is true for all real numbers for which both sides are defined. So notice that my equation, 2x minus 5 equals 2x plus 1 minus 6. If I was to combine like terms on the right-hand side, I would get that 2x minus 5 equals 2x minus 5. So because the left side is exactly like the right side, it doesn't matter what number I substitute in for x, the left side and the right side will always be the same. So that makes it an identity. The conditional equation is an equation that is not an identity. So it's not going to work for every single value of x. However, it's true for at least one real number. So it would just be like your basic solving an equation where there's 4 minus x equals 9. You can solve for x. You would get x to equal a number. And so that number is a true statement, and there's at least one number for that equation. And then you have an inconsistent equation. It's an equation that is not true for even one real number. Okay, so basically something like 2x equals 2x minus 1. You're never going to get the left side to equal the right side no matter what value you plug in for x. So we're going to determine whether these equations are an identity, a conditional equation, or an inconsistent equation. And so to do that, we're going to start solving the equation. So in the first one here, 4 times the quantity x minus 7 equals 4x plus 28. If I distribute the 4 on the left-hand side, that would give me 4x minus 28 equals 4x plus 28. Now, depending on how you wanted to start combining like terms, if I wanted to combine, the x's together, I could move that 4x over by subtracting. And notice then the x's go away and I get that negative 28 equals positive 28. So notice that what I have is a false statement. I cannot have negative 28 equaling positive 28. And so because that's not true, then we have an inconsistent equation. Okay. In number 2, if I have 8x plus 2x equals 9x, well, on the left-hand side, I can combine those like terms. Because those both have x, I'm going to start combining by moving that 9x over to the other side. Notice that that turns into 1x. Over here, that equals 0. So notice I was able to get a value for x, and because I can get at least one number that works for this equation, that tells me that I have a conditional equation. Or sorry, not conditional. Yeah, conditional. Okay. If I take a look at this third one, once again, we want to determine if it's an identity, conditional, or inconsistent equation. So here we have a rational equation because we've got some fractions and those fractions have variables in the denominator. So just like our practice the other day, looking at your denominators, we've got some binomials here. There's nothing that we can do to factor out those binomials. So that means that my least common denominator is that x plus 3. So that's what I'm going to multiply everything in the equation by. So we're going to have x plus 3 times the quantity 6 over x plus 3. Oops. Plus, then that 2 is also going to get multiplied by the x plus 3. And then that equals x plus 3 getting multiplied by negative 2x over x plus 3. So notice that the x plus 3's cancel with the first term, giving you 6. I'm going to distribute that 2 to give me then 2x plus 6. And on the other side, the x plus 3's cancel, and that gives me negative 2x. So if I start simplifying this, notice that I can combine like terms, and I can get 6 and 6 to be 12. I've got some x's that I can move, so I'm going to move that 2x over to the right by subtracting. That gives me now 12 equals negative 4x. I'm going to divide by negative 4, and I get a value of x to be negative 3. So remember, even though I got a value of x here, I do have to, because it's a rational equation, go back and substitute it in to make sure that that could be a solution. So if I'm checking my answer here, notice that when I substitute in my negative 3 into the denominator, I'm going to clearly see that one denominator, in this case both the denominators, end up turning into 0, which is exactly what I don't want. So because technically x equals negative 3 is no solution, it's an empty set, that means we have an inconsistent equation. So even though I was able to get a value for x, I can't just automatically assume that it's conditional. In this case, like I said, because it was a rational equation, we had to go back and check. While the other one, if I go back here, notice that it was not a rational equation. There were no fractions with variables in the denominator. And so that's why I was able to say right away that it was conditional. So just be very careful. Okay, here's another one. Let's determine if we have an identity, conditional, or inconsistent equation. So I've got another rational equation here because I've got equations with fractions where variables are in my denominator. Notice that first fraction is going to be able to factor. I can find numbers that multiply to negative 10 but add to positive 3. That would be x plus 5 times x minus 2. Notice that my other two denominators are not going to be able to take out a GCF or factor any further. And if you notice that, what do all of them have in common? My least common denominator is that very first fraction. Okay, so that's what I'm going to multiply everything by. So hopefully you can kind of tell, okay, if I was to multiply that LCD by that very first fraction, the whole denominator is going to cancel, and it's just going to leave me with my numerator. If I multiply that second fraction by my least common denominator, the x minus 2's are going to cancel, so that means my numerator is really just going to get multiplied by the x plus 5. That equals, if I was to multiply this fraction on the right by that LCD, the x plus 5's are going to cancel, so that means my numerator is going to get multiplied by x minus 2. Okay, I'm going to start distributing so I can start figuring out what kind of equation I have. We've got some like terms on the left, so we really have 3x plus 16 equals 3x minus 6. Notice that I've got some x's. If I move that 3x over to the other side, I'm going to end up having those x's disappear, and that gives us 16 equaling negative 6. Obviously, this is a false statement. 16 will never equal negative 6, and so that tells us that once again we have an inconsistent equation. So there was no value to check for x here because we lost all the x's once we started combining like terms. All right, so I would suggest pause the video and see if you can determine whether or not we have an identity, conditional equation, or an inconsistent equation. With the first one, we actually had an identity because notice that when I started distributing and combining like terms, the left side looked exactly like the right side. And so it didn't matter what value I solved for x. Actually, the x's would cancel and the 4's would cancel. That would tell me 0 equals 0. That will always be a true statement. So that's why it's an identity. In the next one, notice that we had a least common denominator of 6x. If I multiplied everything by that, it cleared away the fractions. I got a value of x to be 6. If I plugged it back into the denominator, I would not get 0, which tells me that that solution does hold up, and so that makes it a conditional equation. All right, let's look at some linear equations here. So we've got a graph on the left, and above we've got a couple of equations, and it's describing the group's average level of depression response to the negative life effects. Okay, so we're talking sense of humor and depression. So it says in part number 1, when a low humor group has an intensity level of 6, what is their level of depression? So notice we can kind of look at the graph right now. Notice that the intensity of negative life of x is going to be on the bottom. That's the x value. And then we're dealing with the depression for the y. Okay, so if it's saying that we have an intensity level of 6, that's going to be on the x-axis. We're looking at low humor. That means we're looking at the blue line. And so if I go up, I can roughly see that it's going to be somewhere in between 12 and 14. And so because we might not have an exact number there on the graph, that's when I would maybe shift my focus over to the equation that's given. So if I go to the low humor group and I substitute 6 in for x, we can figure that out. So we'll have this getting multiplied by 6. All right, so 10 times 6 is 60, so we really have 60 over 9 plus 53 over 9, so that gives us 113 over 9, and if I was to divide that, that gives us, like I said, it's going to be in between 12 and 14, and it turned out to be approximately 12.6. In the second one, it says identify your solution as a point on the graph where the high humor group level of depression is 4. Okay, so I want an ordered pair. And remember, x is going to represent the intensity, and then the y is representing the depression. And so they're already giving us the y value to be 4. So we're going to use then our graph over here for talking high humor. We're looking at the purple line. I'm going to go over to 4 on the y-axis, and if I start heading over and going to the right, I see that that point is clearly at 10. So my ordered pair would be 10, 4. Okay, so that's us continuing to solve linear equations, rational equations, and then now starting to identify these identities as, as identities, conditional equations, or inconsistent.